All right, welcome quantitative literacy students. We're going to play around with the end of lesson 2.3, interpreting statements about percentages. So we built a spreadsheet last time related to smokers, non-smokers, men and women. So now we're just going to take a look at a couple of simpler situations and figure out what we can and can't do about statements with percentages. So whiteboard, please. Here we go. So take a read of that statement. We've got a little information about women smokers in China and women smokers in the United States. So we have this 3.7%. So out of 100 adult women in China, how many women are smokers? So remember, percent means out of 100. So off to the side here, just remind myself, 3.7%, the percent symbol literally means divide by 100. So that's 3.7 divided by 100. So out of 100 women, there's out of 100 in China, about how many? About, right? We can't have 3.7 women, so we would have to say about 4 out of 100. So about 4 out of 100 women in China smoke. All right, so what about out of 1,000? Well, then we just want the denominator to be 1,000 here. So in this case, I could just multiply by 10 top and bottom. 10 times 100 gives me 1,000. So that gives me a new statement where I have, let's see, 37 out of 1,000. Okay. And, you know, we could stick with the 37. We could say it's about 40. So I'm just going to go with the 37. So I'm not supposed to say about up there. About 37 out of 1,000 women in China smoke. All right, so, and we could answer a variety of questions like that. Similar, United States, out of 100 women, well, since this is a percent, that would be 19 out of 100 women in the US smoke. And I'll leave you to do the next one. Hopefully you get the point there. Are there more women smokers in China or the United States? Well, for sure, we know that 3.7% is less than 19%. Okay, so then the big question is, well, if they're the same population, maybe there's only 100 million people in China and 100 million people in the U.S., then that means these percentages would turn into, let's see, if we went with 100 million, 19% of 100 million would be 19 million, I think, and then 3.7 million. So definitely China would have less than the United States. However, they don't have the same population. So we can't answer this question because we don't know the population of the US or China. So I can just make a note here. I need the populations to answer this question. Now, China does have more people. My recollection is China has maybe, is it 3 billion people? It could be too high. Maybe it's 2 billion. United States has, I think, like almost 400 million people, way less, but we have a higher percentage. So we would have to look up those numbers and check it out. So we could do that in a moment. Suppose you read that 590 out of 1,000 men in China smoke. Based on this data, what percent smoke? Well, that's a nice, easy one to clean up. We just take our 590 and divide by 100, right? Because a percent is also a part of a whole. Now, this reduces nicely. So I can just divide top and bottom by 10. And so then I get 59 out of 100, which happens to be 59%, which is kind of nice. All right, so let's just double check the US-China thing. So we can just look that up on the internet. So let's get a new tab here. And we want to know, let's say, the China population. Hello. Oh, search is over here. Sorry, this is a different browser. I'm not used to it. China population. There we go. Okay, I was a little off. It was 1.4 billion. And then the US population is, give me a population here. Guess we'll go here. And US population is about, let's say, 300 million. All right, so back to my board. There we go. New page. So we would have to check. So for China, we've got 3.7%, which turned into a real number divided by 100, times the Chinese population, which was 1.4 billion. So a billion is what? A bunch of zeros. So there's 1,000, there's a million, there's a billion. So 9 zeros there. And we can clean this up a little bit. 100 goes into 2 of these zeros. And that's about it. We just have to multiply this stuff out. So 3.7 times 1.4 times 10 million. Calculator. And come on, Google, give me a calculator. No. Come on, show me the calculator. Does it not work here? Seriously? I gotta get another calculator. Gizmos, maybe? There we go. All right, so I have 3.7 times 1.4 times 10. 1, 2, 3, 1, 2, 3. So counting that out, what do we get? 1, 2, 3, 50, almost 52 million smokers is what we seem to get there. So that's approximately 52 million smokers. If we do the United States, in the US, we had 19%, which would be 19 out of 100, times a population of, what did we say? Was it 300 or 400 million? No, I forgot. US, let's call it 300. 300 million, so 300 million, let's see, there's 1,000, and there's a million. So cleaning this one up, before I plug into my calculator, 100 goes into 300 3 times. So we've got 19 times 3 times a million, which we could kind of estimate. Since we downgraded the population, we could say that's maybe 20%. 3 times 20 is 60, so we would get 60 million smokers, roughly. So it looks like there might be more smokers in the US, but even though China only has 3.7%, they got a heck of a lot more people, so they almost catch up with us with the raw number of smokers. So sometimes comparing straight numbers can tell you interesting things. Sometimes comparing percents can tell you interesting things, and they're not exactly the same. All right, let's see. What else do we need to do here? Next page. Okay, so here we have a couple of different tables. So like when we played with the smokers at the universities, men versus women, there were different ways we could organize the data. So I have 2 different tables here. So let's try to see what they mean. In the first table, morning class, afternoon, A, B, C, D, F. We've got a 12 versus 14% A's and 25 versus 20. If we add up going down, that doesn't seem very meaningful. If we add up going across, we get what? Like 10, 30, 70. Okay, so coming across, the numbers add up to 100% on each of these rows. You can double check that with your calculator. Table down here. We've got, looks like, oh, check it out. Coming down, I get 100%, 100%, 100%, 100%. All right, so interpretation of the tables. Here, coming across, this table is all of the morning class organized sideways. So 12% of the morning class got A's, 25% of the morning class got B's, and so on. Afternoon class, 14% got A's, and 20% got B's, and so on. This table down here is organized not by class, but by grade, because these are all of the A's. 100% of the students that got A's are in this column right here. So of the students that got A's, 44% were in the morning class. Of the students that got B's, 53% of the B's happened in the morning class, and so on down the road. So the tables talk about the same classes, same students, same grades. It's just by percent instead of by number. You can organize it in two different ways. So which table could be used to answer the following questions? What percentage of the students who received A's are in the morning class? So in this case, we want to know what part of the students who had A's. So the second table is organized by grade. So that means I'm focusing on the grade of A. And I want to know what percent of those A's were in the morning class. So I would want table 2. And so you try to come up with an explanation as to why you believe what I believe here, that that's table 2. And again, one reason is when you look at the column of A's, it adds up to 100%, which means that column refers to all of the students that got an A, which is what we're asked about in the beginning of that question. So I'll use some similar reason to figure out part B. All right, so I hope you found this helpful in playing around. I'm going to sign out for now and see you in the near future.